Section 9-2, using formulas for circles and regular polygons. The objectives of this lesson will be to apply the formulas for the area and circumference of a circle and to apply the formula for the area of a regular polygon. Okay, first we're going to cover circles. A circle is a set of points that's in a plane that are at a fixed distance from a given point called the center of the circle. So if this is my fixed point, all of these points around it are the same distance from this point. So they're all equidistant from one point. That's the definition of a circle. The center of the circle is the point inside of the circle. So this point that we were just mentioning that is equidistant from all these points. Let's go ahead and cover the the equation for circumference and area. For circumference, there are two equations you can use. You can take the diameter and multiply it by pi, or you can take 2 times the radius and multiply it by pi. The area of the circle is equal to pi r squared. So you just take the radius. Remember, the radius is from the center to the circle, and you square it, and then you multiply it by pi. Okay, so let's go ahead and do a problem where we use circumference and area with a circle. In this example, they're asking us to find the circumference and area of a circle. Okay, and it says here to leave your answers in terms of pi. Now what that means is do not multiply pi into your equation. We're just going to leave pi alone in the end. So when you put this in the calculator, you should not hit the pi button or 3.14. Okay, so let's go ahead and first find the circumference. Now there are two equations for circumference. There is pi times your diameter, or there is 2 pi times your radius. Here they gave us a circle, and they told us that this whole length right here, this is the diameter, all the way across the circle, is equal to 10 over pi. Since I know the diameter, I'm going to go ahead and use this equation over here. So I'm trying to solve for the circumference, and I know the diameter is 10 over pi. And I'm trying to figure out the circumference. If you look here, these two are multiplying each other. And here I have pi on top in the numerator, and here I have pi in the denominator. So these will both cancel, leaving just 10. So this tells me that my circumference is 10 centimeters. Okay, next they want me to find the area of the circle. So for the area of the circle, the equation is pi times your radius squared. Well, if you look here, I don't know the radius, I know the diameter. But to get the radius, I just have to divide the diameter in half. Right now, I have 10 over pi. If I want to get the radius, I just have to divide this by 2. Basically, you're just dividing the numerator. 10 divided by 2 gives you 5. And then pi is still there. Okay, so I can go ahead and plug this in. The radius is 5 over pi. And the same thing happens here as it did with the circumference. The pi's will end up canceling out. So that means that my area is 5 centimeters squared. Okay, example 2. Find the circumference of circle P in which the area is 36 pi. Leave your answer in terms of pi. Okay, this time we don't know the radius or the diameter. They're asking us to find the circumference only given the area. Now, if we remember, area is equal to pi times the radius squared. So I do know the area. I can plug that in to start out with. 36 pi, that's equal to pi r squared. My only variable, if you look here, is the radius. So I need to solve for r. Now, I want to get r by himself. So first thing is I need to get rid of pi. Now, pi is just a number, so I can just divide by that number. What I do to one side, I have to do to the other side. Now, since this is multiplying and I just divided, these pi's will cancel out. And if you look over here, these pi's cancel out as well. Same thing, they divide out to be 1. So I get 36 is equal to r squared. And now I have to get rid of this squared right here. And so to get rid of that, I have to take the square root of both sides. So r is equal to 6. I know my radius, but that still doesn't answer the question. It says find the circumference of circle P. So now I got to go And I'm going to use this equation, circumference equals 2 pi r, because I know the radius. I figured out that the radius is 6. I can plug this in and solve for the circumference. So 2 times pi times the radius is 6. And this is what it means to leave your answer in terms of pi. It means multiply the other numbers, but don't multiply it by pi. Okay, so 2 times 6 is 12, and we just leave pi next to that number. So the circumference is equal to 12 pi centimeters. Example 3. A pizza parlor offers pizzas with diameters of 8 inches, 10 inches, and 12 inches. Find the area of each size pizza, round to the nearest tenth. Alright, now we're going to go into regular polygons. The center of a regular polygon is a point that is equidistant from all vertices of the regular polygon. So if you notice right here, all these line segments, they're all equidistant from the vertice to the center of the polygon. The apothem is the perpendicular distance from the center of the regular polygon to a side of the polygon. So you go from the center point down perpendicular to one of the sides, and you can draw this to any of the sides of your regular polygon. The central angle of a regular polygon is an angle whose vertex is the center of the regular polygon and whose side passes through consecutive vertices. So one example of the central angle would be this angle right in here. That is a central angle. Or this one, it could be any one of these right here. And the equations for regular polygons for area is 1/2 times the apothem, that's what the lowercase stands for, it's the apothem, what we just spoke about, times the perimeter. Okay, so you have to figure out what the apothem length is, and you're going to multiply that by the perimeter. Perimeter is the sum of all the sides. Okay, example 4, find the area of the regular polygon, round to the nearest tenth. Okay, so for this one, the only information I'm told is that the length from the central point, the center of the polygon, to one of the vertices is 10 inches. To find the area for this regular polygon, I have to take 1/2 times the apothem times the perimeter. Now, I don't know either of these values, and that's what I'm going to have to look for. Now, the apothem is perpendicular from the center to the sides, and you can draw that to any of the sides. And this gives us a right triangle here, if you look right there. Now, I can get some more information from this. I'm going to go ahead and draw this other segment right over here, and there's a reason why I want to draw that. Right here, I've created, in between these two segments, this is the central angle. Now, if I were to go from here and went all the way around and back, that would make a full 360 degrees. Okay, so I'm going to use that information to help me find that angle down there. If I were to draw all of these segments here, that would give me 6 central angles. If I took 360 degrees and divided that by 6, that would tell me what each central angle equaled. So 360 degrees divided by 6 is equal to 60. So that means that the central angle is 60 degrees. But this apothem right here bisects the central angle. So if this whole central angle is 60 degrees, then this angle right here is 30 degrees. And looks like here we have a 30, 60, 90 triangle. So if you remember your 30, 60, 90 triangle properties, you can go ahead and use them. If not, we're going to go ahead and use trigonometry to help us find the missing parts. First, I'm going to go ahead and solve for the apothem, and I'm going to label that side X. And I'm going to use the 60-degree angle to do this one right here. So I have the opposite side and the adjacent side that I want to work with. So I'm going to use sine. Sine of 60 degrees is equal to the opposite over the adjacent side. So to solve for the apothem, all I have to do is multiply both sides by 10. Okay, this ends up giving me 8.7. Next, I need to find the length of the base of this triangle right here. If I can find that, then I can double this and get the whole length of one side. And since I know it's a regular polygon, I know that all the sides are the same, and I can find the perimeter. So this time I'm going to call this side Y, and I'm going to use the 60-degree angle again. It doesn't matter which angle you use, I'm just choosing to use this one. And this time I'm looking for the adjacent side, and I'm going to use the hypotenuse side to work with. So adjacent and hypotenuse means I'm going to be using cosine. Cosine of 60 degrees is equal to the adjacent side over the hypotenuse. And once again here, to solve for that side, I need to multiply both sides by 10. Okay, so here I get that side measures 5. So if this right here measures 5, then the whole length of this side is 10. And once again, like I said before, we have a regular polygon, so all 6 sides is 10. And the perimeter is 60. I now have everything I need to plug into my equation. So area is equal to 1/2 times the apothem, which is 8.7, times the perimeter, and I get 261 inches squared for the area. Okay, let's go ahead and move on to the next one. Example 5. Find the area of a regular pentagon with a side length of 8 feet. Round to the nearest tenth. Okay, so once again here, let's go ahead and just pick, let's say the center is right there. I'm going to go ahead and draw the apothem there. And I'm going to create the triangle like I did before. I'm going to do 2 of these here so I can find the central angle first. So now here, this is the center. And just like we did before, I'm going to start off by first calculating the central angle. Okay, the only thing I know is the side length. The side length is 8, but I don't know the apothem, which is why I still need to find the central angle. If I can get the central angle, I can divide it in half and then work with a right triangle to find the apothem. Okay, so here, if I were to draw these black segments here, I would have 5 of them. And if you remember from the slide before, we would make a full 360 degrees here. If I divide that by 5, I would get 72 degrees. But then this angle right here gets divided, gets bisected by the apothem. So that means that this angle right here is 36 degrees. So I have 36 degrees. This is the side I need to find. I don't know what this length is, but I do know that this whole side is 8. I only want to work with this triangle here. So this triangle here also bisects the side. So I know that this length is 4. Okay, I have my angle. I have 2 sides to work with. I have the opposite side and the adjacent side. So I'm going to be using tangent to help me find what the apothem is. So tangent of 36 is equal to the opposite over the adjacent side. And to solve for x, if you remember, we would have to do 4 divided by the tangent of 36, which gives us 5.5. Okay, so now this right here, this is the apothem. The perimeter, we know one side is 8. We have 5 sides, and this is a regular pentagon, so all the sides are the same. 8 times 5 is 40. So now I have all the information I need to find the area. Area is equal to 1/2 times the apothem times the perimeter. So we're just going to plug this in. The apothem is 5.5 and the perimeter is 40. And we get 110 and we're in feet, so this is feet squared. Okay, make sure to come to class with any questions that you may have. Make sure you understand your definitions of what an apothem is, what the center of a circle and a pentagon is, and have those ready for your vocab quizzes as well next week.